Okay. All right. Now, as a follow-up to last week's study of the periodic table, we're today going to talk about chemical reactions. I have not invited this feline, but if you'd like to follow him, you can follow him on Instagram and Twitter, if you're old like me, at Bert Felinestein, scientific wizard. So this week, we're talking about chemical reactions. Chemical reactions occur when substances undergo chemical changes and new substances are formed. I've written an example of a chemical reaction here, right above Bert's information there. So, the information at the top by Bert Felinestein, this is what water does when it is created. So, in this occasion we have hydrogen, H, plus oxygen yielding water, H2O, which I'm sure you're familiar with. So, on the left-hand side, we have what are called the reactants. Reactants are the substances that are entering the chemical reaction. They're always on the left-hand side of the arrow, which we usually say yields. So the reactants yield what's on the right-hand side. Okay. So in this case, the right-hand side would be the H2O. That is the product. The product is the substance that is created in a chemical reaction. All right. Now, hydrogen and oxygen are interesting because they both exist as gases in nature. And to make them become a liquid is a sign of a definite chemical reaction. So not only is it something new, it's even in a different phase of matter. So this doesn't just happen. There's something required to make a reaction happen, and it's called activation energy. Activation energy is the energy required for a chemical reaction to take place. And that's usually labeled somewhere here above the yield sign, which, activation energy goes somewhere like that. Again, that's not American Eagle, but it's activation energy. That's the energy required to make the chemical reaction take place. Another thing you can notice, and you'll learn a lot more about this when you learn how to balance equations, but just understand that this chemical equation honors the law of conservation of matter. Conservation of mass. And what that means is that however many atoms you start off with on the reactant side, the reactants on the product side should have that same number of atoms. So, and just to quickly label these, this is a coefficient. The big letter in front of big number in front of a letter is called a coefficient. The little thing that's below the line is called a subscript. So, subscript here, coefficient here, subscript here. And you can look at this real quickly, that hydrogen, subscript of 2, with a coefficient of 2 in the front, you say 2 times 2, which is 4. So there's 4 atoms of hydrogen on the reactant side. Now let's see how many are on the product side. Again, over here, there's a subscript of 2, coefficient of 2. 2 times 2 is 4. So 4 hydrogen here, 4 hydrogen atoms over here. So it's been conserved as far as hydrogen. Oxygen, this oxygen has a subscript of 2. So it's 2 atoms of oxygen. On the product side, there's a coefficient of 2. There's a subscript of an understood 1. We don't put that. 2 times 1, there's 2 atoms of oxygen on that side. So as far as the law of conservation of mass, this equation does honor that truth. Thank you.